Today we're starting chapter 6 with lessons 6.1 and 6.2. 6.1 is about ratios, proportions, and geometric means. Now if you've been through an Algebra 1 class or even pre-algebra class, you should have touched on proportion before, and most likely ratios as well. So geometric mean is the main new term. However, ratios and proportions do have quite a bit in common with being similar figures that we're getting into in this chapter 6. So we will cover those as well in regards to how they relate to geometry. So if A and B are two numbers and B does not equal 0, then the ratio of A to B is A to B. Sounds pretty self-explanatory there. The ratio can also be written as A over B. They can also be simplified similar to fractions. Now the only thing I would say about ratios is you can't say, oh, we've got 6 over 1, that's 6. No, because 6 and 1 generally are both needed in that, right? Like saying we have 6 boys to 1 girl in one of the classes, right? You wouldn't just say we have 6. It has to have both numbers. Now, in regards to similarity, we're going to be using it a little bit more often with ratio of side lengths. So down here, we've got two equilateral triangles. ABC has sides 2, DEF has sides 1. So the ratio of side length in ABC to side length of DEF can be written as 2 to 1 or 2 over 1. Both are the same thing, just different ways of writing ratios. Next, we can write them in simplest form. As already stated, we can simplify. So down below, we have a width to length of 7 to 14. Dividing both top and bottom, or numerator denominator of that ratio, by 7 gets us a simplified ratio or equivalent ratio of 1 to 2. Now we can simplify some more. We got 68 meters to 4 meters, right? And generally I like to write it as a fraction, just more comfortable for me in simplifying. But both of these numbers are divisible by 4, and we get 17 to 1. Right, now the meters don't necessarily need to come along with it at the end. In some situations, maybe we will keep the labels. However, if the labels change, you definitely need to convert. We wouldn't have like kilometers to meters, right? We would want to convert so that we would have an actual representation. Over here, 52 meters to 13 meters. They're both divisible by 13. And we're going to get 4 to 1. Last one, 21 to 91. Both meters. Again, both these are divisible by 7. Right? 3 goes into 21, but 3 doesn't go into 91. It goes into 90. But 7 times 3 is 21, and 7 times 13 is 91. So that would leave us 3 to 13. 3 to 13, not 13. Word problem. In plans to paint a mural on a rectangular wall, you know that the perimeter of the wall is 484 feet. You also know the ratio of its length to width is 9 to 2. Find the area of the wall. So generally, whenever I see a word problem, I try to draw out what I can. I'm not going to draw a mural, but just giving a picture so I know I can use this. Now, perimeter is 484, but what I need to know is what is my perimeter made of? And in this case, and also feet, that it has length of 9, width of 2, but it didn't say the length is 9 and the width is 2. It said our ratio of length to width is 2. So to plug in a value here, it wouldn't be fair to say 9 and 2. It wouldn't end up equaling our perimeter, but it's 9 times some number to 2 times that same number, right? Because just like when we had, again, earlier, 52 to 13, right? And we were able to take 13 out of each piece. These could have been rewritten as 4 to 1, and if we wanted our original numbers, 4 times x over 1 times x, where x was 13, right? So even though just one slide ago, right, think about this one, that was 52 to 13, we were able to simplify. So in the same way, because we don't know what our final ratio is going the other way, we have to bring that x into play. So that's where these x's come from. And now, knowing a rectangle, right, we've got length and width on both sides. And if we find, right there, we have one variable. If we add these all together or use our perimeter formula, 2 times length plus 2 times width, as a reminder, equal perimeter. So if we set that up, we can solve to get 18 plus 4 equals 22x. And the perimeter equals up above 484. So now we can solve for what x equals. Dividing by 22 on both sides, we get x is 22. And so now this is 9 and 2, and now our width becomes not just 9x, but it's 9 times 22, which is 198 when we do the math here for feet, and 2 times 22 gives us 44. Now with 198 times 44, we can find the area. And that one's going to be a little bit more for using a calculator. So when we do 198 times 44, we're 44, let's see, 8,800 minus 88. I get 8712. So double checking that quick with the calculator. 198 times 44, and I get 8712. And again, it was feet squared. So that's just one way we can use our ratio to help us out. Ratios. Next, perimeter of a room is 48 feet, and the ratio of length to width is 7 to 5. Find the length and width. Now this is a more standard question. The last one required you to find length and width to find something beyond it. So again, we got length, width, but more specifically, we've got 7x to 5x, right? Perimeter is 48, so again, perimeter equals 2 times length plus 2 times width, plugging in our numbers. Those are from chapter 1:7. If you need to go back and look them up, we get 48 feet. So we got 14 here, 10 here, and they all have x. So we get 24x is 48. And divide by 24 on each side, I get x is 2. Now, that doesn't finish our answer, so be careful. There's many word problems where you've got things like that. Oh, x is 2. Wait. Length and width of the room. So now we need to say length equals 7, x is 2, so length is 14 feet, width is 5 times x, which is 2, gives us 10 feet. And there's our length and width. Next, an equation that states two ratios are equal is called a proportion. Right? So generally we have proportions looking hopefully less variable-like than A over B equals C over D. Now, B and C are considered the means of the equation, whereas A and D, top left, bottom right, are considered the extremes. Okay? So when we have geometric mean, that's going to mean something with this type of means, not necessarily in terms of average. So how do you solve a proportion? Cross multiply and divide. Now, once in a while, we'll have ways such as this problem where, hey, 5 over 10, before we cross multiply, we could simplify and just write this as 1/2. And now when we cross multiply and divide, it's a little bit lower numbers, a little bit easier to do math with. If you're not a 5 times 16 computing in your head type person. But we get 2 times x is 16, divide by 2 on both sides, and we get x is 8. Now just a little note, if you aren't one of these types, you can still solve, just break it down into different pieces. For example, if we did 10 times x equals 5 times 16. Notice I did not multiply them together, right? Because if you aren't that type of doing higher level math in your head or higher number math in your head, don't multiply, but then in the end here, I got x is 5 times 16 over 10. Now, try to cancel like it's a fraction. Okay, so 5 goes into 10 2 times. So divide by 5, divide by 5. Oh, 2 goes into 16 8 times. So going to the right this time. And I get 1 times 8 is 8. So we can similarly do that math without simplifying. Next, we've got 1 over y plus 1 equals 2 over 3y. So we need to cross multiply. Now a note. We get 3y times 1, so 3y, equals 2 times y plus 1. Notice there's a parenthesis. Even though you don't write it That's not 1 divided by y, then plus 1. It is 1 divided by the whole quantity y plus 1. So this is in invisible parentheses in a fraction. So that's why when we're doing this, it's not 2y plus 1, but we distribute 2 times y, 2 plus 1 times 1. So you get 2y plus 2 equals 3y. And then we solve by subtracting 2y from each side, and y equals 2. My y's are going from straight to curl, sorry. You can always plug that back in, make sure it makes sense. So for checking your work, usually I do kind of like a cloud for checking your work. We got 1 over 2 plus 1 equals 2 over 3 times 2. So this is 2/6 equals 1/3, right? That makes sense. 2/6 does equal 1/3, and we're checked. You can also cross multiply here. 6 should equal 6. If they're equal, when you cross multiply like that, then the fractions are equal. If 1 is a larger number, that would mean the fractions aren't equal, and that number would be the larger number. That fraction, sorry. Geometric mean of 2 positive numbers a and b is a positive number x, such that a over x equals x over b. So x squared equals ab, and x equals square root of ab. Right, so generally I use this setup when we're solving. However, it does give me the formula. Now, not all these answers are going to be perfect squares. So here is a reminder on how you would deal with them in probably the easiest way. So what's the geometric mean of 24 and 48? This means 24 over x equals x over 48. And again, we'll get to this point in a second. Then we're going to get cross multiply, x squared equals, and I leave it like 24 times 48. Okay, now 24 is in the number 48, right? 48 is 24 times 2, so I'm just going to break apart that number before I square root. And so now when I square root, I have a perfect square under my square root. One of these numbers is coming out. So at 24 times 24, what times itself to equal that? Well, 24. The 2 having only one number is going to stay underneath the root. And therefore, my answer is going to be 24 square root of 2. Right? We're now looking for, this would be an exact answer. We're now looking for a rounded to 2 decimal answer. So to solve for the next geometric means, some of these will not have a nice square root like the last one did. This is a warning. So again, using the other method, x is the square root of these numbers multiplied. 17, the prime number. 12 can break down a little bit. 12 is 4 times 3. So the square root of 4 is going to give us 2, but then we're left with 3 times 17 under our square root. 3 times 17 is 51. Square root of 4 is 2. So x equals 2 root 51. Now, another way you can break these apart is making factor trees. Right, prime factor trees. So 17's one branch, 12's the other, and then breaking it down, we could do 3 times 4, 2 times 6, right? Breaking it down into prime factor components. So now at the end of each branch is our prime number, right? Prime factorization of what looks to be what? 204 by my math. It's going to be 2 times 2 times 3 times 17. If we have a pair, one of those numbers is coming out, right? That's like the square root of 4. 2 is what comes out. What's left over, if they don't match, right? They need to be an exact pair, by the way. Those go back underneath the square root. So that would also give me 2 square root of 51. Just giving you an alternate way to do that. Lastly, 18 and 54. Again, square root of 18 times 54. 54 is 18 times 3. So now I have a pair of 18s, and one of them is coming out. The other one is, again, kind of eaten up by the square root. And we get 18 square root of 3 is our geometric mean of 18 and 54. Next, using proportions to solve geometric problems. Now, most of the work we're going to do today involves these 4 proportions. Now, notice it starts at 2. The first proportion is A over B equals C over D. And the general rule is if we have that, you can cross multiply to solve. That's the general first rule. Now, what we're going to do is prove that the rest of these work. So talking through them, reciprocal property, if two ratios are equal, then their reciprocals are also equal. Right? Just think about it with real numbers if you're not sure. 2 over 5 equals, let's say multiplied by 3, we get 6 over 15. Is that true if 5 over 2 equals 15 over 6? Right? Yep, that's true. It makes sense. Now that's not proving it, but just showing you in an example. Next, if you interchange the means, now reminder, means are the bottom number of the first ratio and the top number of the second, right? So we got A over B equals C over D. We flip them around, A over C will equal B over D. Now keeping with these numbers that we have here, let's do that. With 2 over 5 equals 6 over 15. Flipping these diagonals here, we get 2 over 6 equals 5 over 15. And both those equal 1/3. Last one, in a proportion, if you add the value of each ratio's denominator to its numerator, then you form a true proportion. Right? So this one is going to be, again, let's do it one more time with our numbers. Right? And so adding the numerator to the top, we're going to get 2 plus 5 over 5, which is going to give me 7/5, versus 6 plus 15 over 15, which is going to give me 21 over 15. Both of those are still equal, right? We still have the times 3 kind of rule going on. So, using the fact that we can cross multiply, we can prove all these. Okay, so all it means, and this is on your homework, so keep close track here, how can we start with this and end with B over A equals D over C? So cross multiplying, we get A times D equals B times C, and now I want A and C in my denominator. So if I divide this side by A, we're going to have D left over. I also have to divide the right side by A. So I'll have A in the denominator. Now I want to get rid of this C because I need a C in the denominator as well. So I'm also going to divide by C in both denominators. So that way, I'm going to cross out with a new red pen here. What's going to happen? This C will cross out, the A will cross out, and what's left? D over C equals B over A. Now it looks opposite order, but this is like saying 3 over 1 equals 6 over 2. Either way you say it, it still works. 6 over 2 equals 3 over 1. Next, the same idea, but we have the means flipping. So again, cross multiplying. This is kind of like our given. This is our proof per se. So cross multiplying, we've got AD equals BC, and now I want C and D in my denominator. So I'm just going to divide by CD on both sides. Similar to the first one, the D's will go in first, the C's in the second, and we will get arrow. A over C equals B over D. So what happened? Our means switched positions. Last one, and this one's the one kind of I like the most just because it's different, is A over B equals C over D. You will not cross multiply to get to this next part, right? We technically could and it would still work. However, what we're going to do here is we're going to add 1 to both sides. Plus 1 equals C over D plus 1. Well, reminder for rules with fractions, in order to add, let's say 1 to each side, I need to make sure that it has the same numerator, or sorry, same denominator, pardon me, as our what we're starting with. So I'm going to multiply this one by B over B so that we can add here. And on the left side, I'm not going to do B because we're just going to stay on the same side of the equation. We'll multiply by D over D so that we'll have the same denominator. So we ended up with A over B plus B over B equals C over D plus D over D. And now since we have the same denominator, we can rewrite this as one fraction. So A plus B over B equals C plus D over D. And that's how that one works. It's the same as adding 1 to both sides. And if you look at the last slide in our numbers, that's literally what happened. We went from 2/5 to 1 2/5. Now we wouldn't say it like that because it's a ratio, but just showing you out loud that that's what happened. We added literally a whole 1 by adding the denominator to our top number or our numerator. And again, they are ratios, so maybe you should call them denominator numerator, but that's kind of That works. Next up, says in the diagram, Mn over Rs is equal to Np over St, right, for true proportion. So these numbers here are just for backup so that we can show they work. Yes, we can solve for x, but that's not what it's asking. So for true proportions would just be to set up, we're going to use the original for our first one. Mn over Rs equals Np over St. Maybe I should have rephrased it for 3 new proportions. Now, again, rule 2 was we can flip them, reciprocal, right? So that means we can switch positions of Rs and Mn and St and Np, and we will have a new and still equal proportion. Next, number 3 was we can switch our diagonals. The bottom left, top right can flip and will still equal. So Mn over Np equals Rs over St. Lastly, the trickiest one for most people to remember is Mn over plus, right? The fourth rule is we're going to add the numerator, the bottom number of each one to the numerator. So Mn plus Rs over Rs equals Np plus St over St. So those are my 4 proportions. So if I go through some of these slides a little quick when I'm hitting next, feel free to pause. We're about 20 minutes late for that one. In the diagram, BD over DA equals BE over EC. Find BA and BD. Well, BA is X. So once we find X, we can do X minus 3 to get BD, right? So using the proportion, we've got BD over DA. I don't know what BD is. We can also solve for that as well. So we'll just say BD for now is Y, and we'll solve for it. So we got Y over DA is 3 equals BE is 18 over EC is 6. Right? Now cross multiply. And again, technically right here, this number, even though we're generally dealing with ratios, that can simplify to 3 over 1. So y over 3 equals 3 over 1. And then when we cross multiply, 3 times 3 gives us 9. And since we're solving for a variable, just 9 divided by 1 is 9, and y equals 9, which is BD. So now filling that in, what is x? Well, or BA equals 9 plus 3, and is therefore 12. Next, it says find AC. Okay, so what we have here is, we haven't really gotten to this part yet, but this is going to be coming up soon. But what's going to happen is we can compare this side to 12 versus the whole side x to AC. So this proportion, they probably should have given to us because we don't have the rule yet. BD over DE equals BA over AC. This is because of similar triangles, so just filling in what we have. Now we've got BD, so 9 over DE, which is 12, equals BA, which is also 12, over, we don't know, AC. Okay? Again, you can simplify or cross multiply, so we'll just do it that way. 9AC equals 12 times 12. Divide by 9 on both sides, and we've got a 3 for each 12. Right? Divide by 3, we get 4. Divide this 3 by 3, and the 12 by 3 get 4. And 4 times 4 is 16, is our AC. One last challenge one before we wrap up. This one is one you definitely need to know. Now, what they give us is given A1 equals K times A2, B1 equals K times B2, C1 equals K times C2. Now, we've got all these same things with K, but more importantly, we can use these to make a proportion, right? A1 divided by A2 on both sides gives us K. Same thing with B1 and B2. B1 divided by B2 equals K, and C1 divided by C2 equals K. So those all equal K. how can we show A1 over A2, sorry, A1 plus B1 plus C1, right, quantity, divided by A2 plus B2 plus C2 equals K. So what we're going to do is take this first piece and we're going to manufacture the rest. So starting here, what we need to do is, well, I'm going to try to make this left side A1 look like A1, B1, C1. So I'm going to add B1 and C1 to both sides. This is what I'm doing, showing the work, just so you're not like, what? Where did they all come from? We get A1 plus B1 plus C1 equals KA2 plus B1 plus C1. Notice, I did not add KB2, KC2 to the right side. We can substitute for that. But now looking, where am I at? I got a lot of parentheses here. But this side already looks pretty much of a match to what I have here, right? So now I've got K over here, but it's not, I just can't get rid of the A2, B1, B, and C1. So what I need to do is substitute. I want to bring that B1 is KB2, so I'm going to substitute there. Same thing here, KC2 equals C1. And the stuff I was doing earlier, maybe a different, sometimes I'll show you that instead of what the given is. So just be aware it will be a similar problem if they give you those proportions we just had. And now substituting, this was KB2 and KC2. And now everything has a K in it, so I can factor K out. If I take K out, I have A2 plus this one taking a K out, I've got B2. This one's a B2. And taking a K out, I have C2. And now that looks awfully similar to this denominator, which conveniently enough, I'm going to divide both sides by so that I get A1, B1, C1 over A2, B2, C2 all added together will equal K. Right, divided by this parentheses portion on both sides, and I get completed that K equals A1 plus B1 plus C1 all over A2 plus B2 plus C2. And that wraps up today's lesson. Make sure to check the homework on Google Classroom.